Good morning, ladies and gentlemen. So today we have one interesting video on quadratic functions. So this video basically looks at the method which we can use to solve quadratic functions. So the first method that we have is by factorization. So this is the common method which everyone knows. And we know that by factorization, you need to find what are referred to as product, sum, and factor. So let us basically get one equation and solve it using by factorization method. So we can get x squared minus 4x minus 5 being equal to 0. So when you are told to solve this equation by factorization method, you need to find the product, sum, and the factor, where the product is the answer that you get when you multiply a times c, and the sum in this case is always b. So when we are told to identify which one is our A, which one is our B, and which one is our C, we follow what is referred to as the general quadratic equation, which is ax squared plus bx plus c, where the one which always has an x squared is an A, the one which always has an x is a B, and the one without any variable is a constant, which in this case is a C. So in this case, for you to basically find the product, you multiply 1 times negative 5, which you get the negative 5, and the sum is always given in between here, which is negative 4. The two numbers called the factors are the answers, which when you multiply, they give you negative 5, and when you add, they give you negative 4, and those numbers are negative 5, 1. Because we know for sure that 1 times negative 5 is basically negative 5, and negative 5 plus 1 is basically negative 4. So from here, we solve this using factorization method by making these factors replace the negative 4, in this case the sum. So we will have x squared, you can replace these anyhow, plus x minus 5x minus 5 being equal to 0. Then we can draw an imaginary line there. So we can say that x can be factorized, so you will remain with x plus 1. And also here, negative 5 can be factorized, you remain with x plus 1 being equal to what? 0. Then from here, you group what is outside, so you have x minus 5, and only collect one bracket because they are the same. Then from here, we equate each of these brackets equal to 0. So we have x minus 5 being equal to 0, where x here is equal to 5. And we have x plus 1 being equal to 0, where x is equal to negative 1. So this is how basically we solve quadratic equations using factorization method. The one that we have next is completing the square method. Completing the square method. So under completing the square, the rules under here, they're a little bit ambiguous and very long to follow. So let us follow closely so that we are not lost on the way. So let us have this equation, which is x squared minus 4x minus 4 being equal to 0. So the first thing that you do when you are given an equation for you to solve using the completing the square method, you first check the coefficient of x squared. If there is a number or any sign in front of x squared, you need to divide the whole lot of this expression by that very sign or number. But in this case, there is only positive 1. So if we are to divide this with positive 1, this will still be the outcome. Then the second thing is that you take your negative 4 to the other side. In this case, you are taking c to the other side, and you have negative 4x is equal to 4. Then the third thing that we basically do is you get the value for b, in this case, which is negative 4x, and what you do, you multiply this by half. So immediately you multiply this by half, you will basically get negative 2x. So immediately you get negative 2x, you will make sure to say you get rid of this x here, and I will make another video why we usually get rid of this x, but for the sake of simplifying math, you just get rid of this x. But immediately you get rid of this x, you need to apply a square, so that when we put it together with this x can basically come back. But immediately you do this, you need to forget about this, your 4x. So you will have x squared positive negative 2 x squared is equal to negative 2 squared plus 4. So immediately now you basically do that. We know that these squares are the same, so you can put these in basically one bracket. And we know that negative 2 squared is basically 4. So x minus 2, where 4 plus 4 is basically 8. And you know for sure that for you to remove this square, you introduce what is referred to as the square root. So you have x minus 2 squared is equal to, you know that the square root of 8 is basically positive or negative 2 the root of 2. So this is the square root of 8. Remember under sets and rationalization, where 8 is the same as 4 times 2, and the root of 4 is 2. So the root of 8 is 2 the root of 2. Then immediately now we do that. This is where now we basically apply some mathematical rules, where we know for sure that if we were to we have cancelled this already. There is no need to rewrite this 2. Sorry. Then negative 2 can go to the other side, and you have x is equal to 2, positive or negative 2, the root of 2. Then from here we can just separate. So we have x is equal to 2 plus 2, the root of 2, or negative 2 minus 2, the root of 2. So this is how basically we solve an equation under quadratic equation using completing the square method. But there is one method which is very much vital, and that method is by formula. So by formula, how do we basically use the formula method to solve an equation which is given to us? So what we will do is we'll get the general quadratic formula, which in this case is ax squared plus bx plus c being equal to 0. So the first thing that you basically do is, remember, we want to derive the general quadratic formula. So the first thing that you do is you divide the whole lot of this expression by a. So this and that cancels, so you have x squared plus bx over a plus c over a being equal to 0. The second thing that you do is you take this to the other side, and you have x squared plus bx over a is equal to negative c over a. Immediately you do this, you get the value of bx over a and multiply this value by half. This is a rule, not something to debate on. So we know for sure that this times that is basically bx over 2a. But immediately you do this, you forget about the x, but immediately you forget about the x, you add the square, so that when you apply the mathematical rules again, the x can definitely come back. But immediately you do this, you need to forget about the guy on the middle there. So this guy, we forget about him, and we have x squared plus b over 2a squared. What you do this side is what you also do to the other side. You add the same expression both sides, and you have b over 2a squared minus c over a, where we know basically that this is the same as x squared plus b over 2a squared equal to this. We can simplify it, it will become b squared over 4a squared minus c over a. Then immediately now we do this, we now get this and put them in one bracket because both have squared, and you have x plus b over 2a squared is equal to b squared minus 4a squared minus c over a. Then immediately now you do that. What you need to understand here is for us to remove this, we apply what is referred to as the square root. So we can apply the square root both sides. So immediately you apply the square root both sides, you basically have x plus b over 2a being equal to positive or negative. Remember, the square root of a number is both positive or negative. Then we know that what basically transpires here is you having a fraction, and you learned how to solve fractions. So this, we can take it to the other side, and you have x is equal to negative b over 2a, positive or negative, where you know that here the common denominator you have is 4a squared, where 4a squared into 4a squared is 1. 1 times b squared is basically b squared, minus a into 4a squared is 4a. 4a times that is 4ac. Then you continue with your square, where we know for sure that now we can have x is equal to negative b over 2a, positive or negative. You know that this will basically give you b squared minus 4ac, where the square root of 4a squared is basically 2a. And 2a now has become common, so we can have negative b plus or minus b squared minus 4ac over 2a. So this is how basically we derive the quadratic formula. Then immediately we derive the quadratic formula, we need to understand that we have this, what is inside, called the discriminant. So this, called the discriminant, is what we use for us to determine what are referred to as types of roots. So how do you determine the types of roots? We need to understand that basically when determining the types of roots, you basically have three types. You have two different real roots. Apart from you having two different real roots, you have equal real roots, and you have an equal real root. So an equal real root, we call these no real roots because the value of the discriminant is lesser than 0. So basically now when we are dealing with these, we need to understand that how does this discriminant apply here. So when you have b squared minus 4ac to be greater than 0, then you have two different real roots. But if you have b squared minus 4ac to be equal to 0, then you have equal real roots. And when you have an equal real root, meaning b squared minus 4ac is lesser than 0. So how do we now basically use this discriminant for us to determine the types of roots? So the question reads to say, what type of root does this basic equation here have? So for you to know the type of roots, you need to get in the discriminant. So we do not know what the answer will be, so do not equate it to anything. So we have negative 3 squared minus 4, 5 times 1. So this is what we basically do there. So we know for sure that this is 9 minus 20, which when you subtract, you get the answer to be negative 11. So we know that this negative 11 now gives us to say we have no real roots. The reason why we have no real roots is because this value is lesser than 0. The other equation that we can get here is where we say x squared plus px plus 9 being equal to 0. So I tell you to say for what values of p will the equation have two real roots? For what values of p will the equation have two real roots? So how do you basically solve this? So this is already a clue on its own, two real roots. So if it's two real roots, meaning it is greater than 0. So you have b squared minus 4ac being greater than 0, where there is b, we put what? P, because p in this case is the one which possesses the qualities of b because there is an x attached. So the value of a is 1 and you have 9 greater than 0. So this is p squared minus 36 having greater than 0. Then immediately you do that, we will have p squared greater than 36. So we introduce the square root both sides, and you have the value of p to be both positive or negative. 6. Remember that this is an inequality, and if you're having an inequality, you need to basically test the answers. So we need to understand that the value of p here can be p modulus greater than 6, meaning the values of p, when we basically put any value of p, so long as it is negative, it will turn to positive and the answer will be greater than 6. So we can have the last example under types of roots. So the last example we can have is 2 squared plus 3x minus 5 equal to 0, where we know for us to get the type of roots, we know for sure that if we are to get this discriminant, you just plug in here. So this is what you basically produce. So you have 9, this is 20, giving you 40, and this is giving you 49. And you know that 49 is greater than 0. So if it is greater than 0, then you have two different real roots, because you know if you were to continue, you will get the root of 49 to be basically positive or negative 7. So this is where we end for today, but I will make another video where we can share knowledge on how to graph quadratic equations. Your host, Golden Zulu.